Hi, I'm Ahmed Daud, and in this session, we are going to start the module on supervised learning classification. So, just recall in the session of introduction to machine learning, we have studied that supervised learning, which is, it's a type of machine learning in which we have a labeled data, or you can say the learning under some supervision. We usually categorize as supervised learning. So supervised learning tackle two type of problems, regression problems and classification problems. Or you can say in the supervised learning, we have two types of algorithms. One type of algorithms that deal with the regression problems, okay, and the other that deal with the classification problems. And sometimes we have the same algorithm that can work for both regression and classification, just a little bit tweakness in the algorithm, and it will work for another type also. So in the regression case, we have learned in the last module very well a linear regression actually, in which there our target variable is continuous variable. Let's say we have to predict the price of a house, we have to predict if the miles per gallon, if we have to predict the rating, continuous rating, either it is in between 0 to 5, but the values are continuous. Values can be 4.2, 4.2, 3, 4. The values are continuous. Is the temperature going to be tomorrow? So in the problems in which we have our target variable as a continuous target variable, then we call that this is a regression problem. So for that we have learned linear regression algorithm in the last session, in the last module. In that session, or in that module particularly, we will discuss supervised learning classification algorithms. So what type of classification problems in which we have a categorical target variable? In our target variable, we have some classes that we have to predict by our model, like email is spam or not, this customer will retain or not, the coming customers, or which person is going to be bankrupt or not, either this person or this or you can say this guy is a thief or not. In that way we can say, when we have two multiple clauses, multiple categories, and we have to predict either our sample belongs to that category or that category, okay. So of course for that also there are multiple algorithms, like a logistic regression, decision trees, random forest, and a lot of others also. Okay, so classification problems in there is no restriction on the classes. In daily routine there are multiple problems, and each problem, in according to each problem there are a number of classes in the target variable. Like in the case of, if the problem is we have to train a model or design a model that can classify either this email is spam or not, then we have just two classes, the email is spam or not. Just two classes in the target variable. And there can be problems when we have multiple classes. Let's say a very famous and dataset, which is dataset of iris, in which we have multiple classes: iris tosa, iris can be versicolor, iris can be virginica. There are three classes in that dataset. In this way there are a number of problems that we face in daily routine, in which we have multiple classes, and we have to classify that this sample or this particular sample belongs to which class out of the given classes, okay. So, in the start of that module, we will restrict our self towards the binary classification, in which we have just two classes, like yes and no. Is it email is spam or not? True or false? Usually, we do not like these are the categories, but when we dealing in our we are doing coding, we usually have binary classification and values one and zeros in our target variable, okay, in the form of 1 and 0. So that type of as there are just two classes in it, so that's why we usually call as primary classification. This problem is There are just two classes here. Okay. So first of all, in the very first, we will discuss the logistic regression. Logistic regression will be the first algorithm that we will see in that module, and you will see a lot of reasons like why it is called regression. Either it is a algorithm for classification problem, why it is called as a logistic regression. Okay, we will also see what's the reason behind that, and why it is logistic. So before going to start that logistic regression, we will see logistic regression in the coming sessions. So before going to start logistic regression, I want to discuss a function which is logistic function. Why I am going to discuss that, just because the logistic function will use in that algorithm. So we should have some sort of idea before to start that algorithm. What is actually logistic function is in according to maths. So okay, logistic function, as this function will use in logistic regression, which is actually a classifier, or you can say algorithm for classification. So in mathematics, there is a function which usually called sigmoid function, which has characteristics that you can say it has S-shaped curve. Okay, sigmoid functions, those type of functions which have S-shaped curve. Okay, there are multiple functions that uh, also called sigmoid functions. Okay, so this is the characteristic of a sigmoid function. So there are multiple functions like a logistic function, hyperbolic tangent function, arctangent function, and many more are. Okay, and all the functions have their equations. So like here you can see, and each equation can produce S-shaped curve. Okay, so hyperbolic tangent function, which is also called tanh function, also used as an activation function in neural network very widely. But here we are just interested in the logistic function. What is logistic function? Okay, so you can say logistic function is one of the type of sigmoid function. So that's why some people also use a logistic function, and sometimes they use the name of sigmoid function. Okay, when they are discussing logistic regression and using the sigmoid function name, or talking about the sigmoid function, then you should understand that they are talking about the logistic function. Okay, the reason is that because logistic is a sigmoid function, logistic can produce S-shaped curve, so that's why they call that also as a sigmoid function. So no worries about that. You can use both names for that function. But when we will go in deep learning, then we have to do some restriction that either it is a logistic function or either it is a hyperbolic tangent function, or what type of S-shaped function is we are using here. But here for the case of logistic regression, we are interested in just logistic function. Okay, so usually it is denoted by lowercase sigma, which is in this way we can write that sigma. Okay, and if we will pass a value here in that function, let's say we are passing a t value here, the equation will be in this way: 1 over 1 plus e raised to power minus t. Okay, t can be any value from minus infinity to positive infinity, and the result of uh, after taking a logistic function of t value, we will get uh, the range which is in between the 0 to 1. Okay, so in other words, you can say logistic function has a range of 0 to 1. Okay, it squeeze any value between 0 to 1. Let's say you will pass 9,44,000 in that function. Here, this function will convert that value into some value between 0 to 1. Okay, how it converts, we will also see. Okay, so first of all, this function here, you can see here, let's say here I am showing you here, this can produce S-shaped curve. If I will change my color, okay, so this is S-shaped curve. You can see here this blue one, it's a logistic, it's a curve of a logistic function. Okay, and which is producing here if you will pass the value 0 here, Like in other words, you can say that t is equal to 0. If t is equal to 0 here, then you will get value 0.5. Okay, uh, you can check it here. If you will pass 0 in that function, e raised to power minus 0 will be of course 0, and in other words, e raised to power 0 is always 1. 1 plus 1 is equal to 2, so 1 over 2 will be 0.5. Okay, so when you will pass a 0 value to this function, it will produce or it will give you 0.5 value here. Okay, and when you will pass some positive infinity, let's say positive infinity, any value very high, or you can say when you are passing positive infinity, you the value closer to positive infinity, you will get answer closer to 1. Okay, here you can see, as your value, as your x-axis is growing here, you are passing more and more higher value, your output will be more closer to 1, but not exactly equal to 1. Okay, exactly equal to 1, because you cannot reach towards the infinity. In that way, you can say you cannot reach towards the exact 1 here. Okay, here, if theoretically, you can consider if you are passing positive infinity to that function, let's say e raised to power positive minus, and into bracket there are positive infinity. So this will become overall, this will be become e raised to power minus infinity, and you can also write in this way, e raised to power 1 over e infinity, and this e infinity will become if you will take infinity power to e, it will be infinity, of course. So 1 over infinity is also become a 0, and 1 over 1 plus 0 is equal to 1. Okay. As you are going towards the infinity, yeah, as your input is growing towards the infinity, your output will be closer to the 1. Okay. If you will pass the value closer to minus infinity, let's say pass a value close to minus infinity, any t value here, and your result will be here, minus minus will be plus, it will be infinity, and 1 over 1 plus infinity, of course it will be 1 over infinity, and 1 over infinity, it's always equal to 0. It's a theoretical concept of mathematics, or in other words, you can say if you will pass a very very small value to that function, like closer to minus infinity, you will get the result closer to 0, but not exactly 0. Here you can see, as you are going towards this side, as you are going to this side, you are getting the result, you are getting your this blue color is showing here, this blue color showing that you are getting your result closer to 0, but not exactly equal to 0. Okay, so you have seen that how if your value is very large, it will be closer to 1. You will pass a very large value to that function, it will be closer to 1. If your value will be very small value, you are passing it to logistic function, logistic function will output it closer to 0, and you when you will pass 0 value into that function, then you will get a output of 0.5. Okay, so in other words, you got an idea. This sigmoid function squeeze any value in between 0 to 1 range. Okay. So this is also a big advantage of a logistic function. That's why we will use that function in the logistic regression. Okay. So you have seen that points also. The last point is inverse of the logistic function. Okay. If you want to see that function, um, the concept of uh, that function, if you want to see here, let's say uh, how it is in between the range of 0 to 1, you can see here conceptually also. Let's say you have here t in range between 0 minus infinity to positive infinity. Okay, let's say here, and if t is in between minus infinity to positive infinity, then the range of e raised to power minus t will be in between 0 to infinity. Okay, if you will take a power like minus infinity, then your result will be infinity. Here, if you will take power e raised to power minus t, the t will, if t is positive infinity, you will get 0, you know that. Okay, so if you will add 1 in that e raised to power minus minus t, then your range will become that from 1 to infinity. Okay, 0 plus 1 you can consider 1, and infinity plus 1, of course it will be infinity. Okay, when you will divide 1 by that, you can say that term here, if you will see that term. Okay, divide 1 by that term, and this term have a range of 1 to infinity. So when you will divide 1 by 1, it will be give you 1 here. Okay, and when you will divide 1 by infinity, it will have 0. Okay, so now overall your range of that function will become 0 to 1. Okay, so in other words, you can also see in that way. Okay, there is no uh, you have to learn that all the points, just to give you the concept that this function squeeze the value in between 0 to 1. Okay, any value you will pass to that function. So sometimes in some books you will see logistic function, and the people sometimes using the name of logit function. So we will also discuss what is actually logit function. So here, logit function is the inverse of, you can say, logistic function. Okay, let's say we know that uh, p, which why here I am calling p, because you know, this sigmoid function produce the range between 0 to 1. Okay, so we also sometimes use this sigmoid function to consider as a probability, because it is giving you always value between 0 to 1. So you can consider it also as a probability. So that's why sometimes you will see that sigmoid function will be denoted as a probability in the case of machine learning, or most probably in the case of logistic regression. Okay, so if you have, let's say you have equation like here, uh, P is equal to sigmoid of T. Okay. So what is logit? If you will take logit of P, logit of P, which is probability, and of course this will be in between, this P will be in between 0 to 1. Okay. So this will give you a T. Okay. The input that you have given to the logistic. Okay. You can consider in other words like here, uh, T is equal to sigmoid minus 1, like you are going on the other side, so that's why it's like a inverse. So p, so you can say this is actually logit. Okay, that's why you can say that logit is the inverse of logistic function. Okay, sometimes you also see that name also. What is that logit function? You have seen it's the inverse of logistic, and sometimes you will see the notation for that, like this t. If you will pass a probability, uh, or you can say the output of logistic function to the logit function, and you will sometimes see in that way. Okay, the formula is represented in that way: natural log of p over 1 minus p. Okay, so usually sometimes people also call it as a log odds. Why is it is called as log odds? Odds, you know, odds mean chances. Okay, so p is probability. Okay, you know, p is a probability which will have a result between 0 to 1. Okay, so it means that the what is the probability of getting 1. Okay, when you are uh, dealing with some let's say you have some uh, classification problem, binary classification problem, and you have target value, target variable as 0 and 1. So okay, so this probability will give you some chances, how much chances that this value is going to be 1. Okay, so that's why some people also, you will see that this is a probability of, or you can say this consider as a chances of getting 1, and sometimes you will see that this is chances of getting 0. If you can consider p as a chances of getting 0, then the lower term will be considered as a chances of getting 1. Okay, so you can see p and 1 minus p, 1 minus p, it's just opposite side of p. Okay, so that's why you can this is called odds. Okay, odds ratio also. P by 1 minus P also called odds ratio. Okay, odds ratio means the ratio of odds. Okay, and odds is chances of getting one divided by chances of getting one and chances of getting zero. So ratio of both odds, that's why it's called low odds ratio. And natural log of odds. Okay, and this is called logit. Okay, you will also sometimes you will see that name log odds. Okay, so maybe you will be a little bit confused how this natural log of p or 1 minus p. It is exactly the same as if you will see that this is a p, which is of course you are taking sigmoid function of some t value. This will be in this way 1 over 1 plus e raised to power minus t. Okay, if you want to write that equation into some other format, you can write in this way, like t is equal natural log of p divided by 1 minus p. Okay, so both these equations are exactly the same. Okay, this and this are exactly the same. Okay, you can write that equation in that way also. Okay, we will also see how you can uh, this equation is equal to this. Okay, so when you will see the term in that way, you will say that it is a logit function, and it is representing in the form of logit function. And sometimes you will see t is also, people call that t, calling the t as a logit. It is logit. Okay, sometimes okay, when you do your research and you are working, you are reading some books or going to some sites, you will see that type of names like logistic function, sigmoid function, logit function, logos. Okay, so that's you will not confuse with these terms. So that's why I am explaining it here. Okay, so here let's say we if we want to prove check either this t is equal to log odds is equal to is the same as that logistic function, we can see also here. Let's say uh, you have this equation and you want to go towards the another notation. Okay, you want to go from logit to the towards the logistic function. Okay, you you can go direct in that way. Okay, let's say it is t, and this is natural log, so that's why it is natural log. You know, it's a log having base e. Okay, so log having base e and p divided by 1 minus p. Okay, so here you know also about the it's a characteristic of logarithm, that if you want to change your you want to convert your natural logs or your equation into form of some exponential equation, you can also convert. Okay, like here I have written in this way. It is exactly the same this one. Okay, here the base comes towards this side, and it will become e raised to power t. Log will remove and this will become 1 over 1 minus p. Okay, you know, it's a characteristic of natural logarithm, and you can see it, if you know about the some different characteristics of logarithm, it will be not difficult for you. And you will see it's available on the internet, what are the characteristics of logarithm, and it's really interesting. Okay, you are here instead of in the form of logarithm, you are writing your equation in the form of power or in the form of exponential. Okay, so here just I am multiplying this term or with that e raised to power t, and you can say I am taking this term on the other side of the equation. Okay, 1 minus p. When you open that brackets, you will get equation in this way: p is equal to e raised to power t minus e raised to power t. into p. When you will take this term minus e raised to power t into p, this term particularly on that side, it will become p plus e raised to power t p. When you will take a p as common here, it will become 1 plus e raised to power t. And when you will divide that equation 1 plus e raised to power t, you will have this equation, and this is exactly the logistic equation. And you can also write in this way: if you will multiply 1 over t on the upper side within the numerator and denominator both, you will get that like this e raised to power t, and this will be cancelled out here. This will be 1, and this will also cancel out. This will also become 1, and here will be 1 over e raised to power t. 1 into 1 raised to 1 multiply with 1 by e raised to power t, it will become in this way. And you can write in this way: p is equal 1 over uh, e raised to power, it's e raised to power 1 over e reciprocal of that. It can also write in this way: e raised to power minus t. So here you got that. Okay, so it's I don't want to make this session so difficult or so long, but unfortunately it become but here just to give you the concepts, what are these terms, okay? Because sometimes simultaneously these terms are using like these terms logistic function, and sometimes you will see that people are using sigmoid function. Okay, simultaneously these names are using people. um, Sometimes okay, so we also have seen logit function. Logit function is nothing, just the inverse of a logistic function. Here you can say it's an inverse of logistic function. Okay, so if you will take a inverse of logit function, it will become logistic. Okay, so also logit function is also called logots. And I have also told you why it called logots, because of logit function representing in the form of natural log of odds. Odds is actually the chances of getting 1 and chances of getting 0, ratio of both chances. Okay, so this will be t. Okay, here you can see. So I hope you got an idea what is logistic function. Okay, it's purely some mathematical function which has S-shaped curve denoted by or represented by the lowercase sigma, have equation 1 over 1 plus e raised to power minus t. It squeeze any value from minus infinity to positive infinity. It squeeze any value into the range of 0 to 1. Logistic function also can be you can say presented, or also can be written in the form of logit function, because these are just inverse of each other. And okay, so I hope that it's enough about the logistic function. So we will meet in the next session when we will start our first classification algorithm, logistic regression, and you will also see why we call logistic regression as we have a regression name in the classification algorithm. Okay, and I hope you got an idea why we are calling logistic regression as we have a regression in the name of logistic regression or classification algorithm. So for now, thank you.